Okay, today I will present our works called real-time static and dynamic gesture recognition using mixed space features for 3D virtual world interaction. This is our outline. First, we will introduce our works briefly, then we'll go through the proposed method that we built. First, we will go through the system architecture that we have, then hand segmentation and arm removal, uh, and go to the gesture type identification, the 3D and 2D feature extraction, static gesture recognition, and then go to the dynamic gesture recognition. After explanation about the proposed method, we are going to present our experiments and result of our approach. Here we have the experiment setup, gesture design for the test our approach, then experimental results of our method. The last is we will present our conclusion and future works. In our works, we are focusing on the problem of recognizing static and dynamic hand gestures. And in this work, we are currently aiming to use this recognition hand gesture recognition system for the virtual reality input actions. Our approach consists of a combination of 3D and 2D space feature that we extract from the uh, RealSense sensors camera, and then by using that combination of 3D and 2D space feature, we will use it for gesture recognition system. And the 3D finger position will be represented as 3D features, and then the 2D shape of the hand as the 2D feature. We will use the SVM and TTW model to solve the hand gesture recognition problem in separate way. We also designed 9 gestures to test the robustness of our works. The gestures consist of 3 dynamic gestures and 6 static gestures. Here the next we will explain briefly about our method one by one. Our proposed method actually divided into separate parts. The first part is about the hand segmentation and arm removal problem, and then following with the gesture type identification to separate the type of gesture, which is we know as a static gesture and dynamic gestures. And next we will extract the 2D and 3D features of the hand as mentioned before, and then the 3D features will be represented by 3D finger position that we will extract using several methods that we have, and then 2D represented by the convex hull of the hand and contour, and also contour of the hand. Then the last step we will solve the static gesture recognition and dynamic gesture recognition separately. We will use SVM and TTW as explained in the introduction. Here is our system architecture. The left one is a simple version of our architecture, and the right one is the tailed version, including the all step. And as you can see that the raw data from the RealSense we got from the camera, and we use the data preprocessing step for the hand segmentation and tracking and filtering, and then we use that for the gesture type checking that we will explain after this. And with that gesture type checking, we will get to know the hand, which is the hand which the gestures belong to the static gestures or dynamic gestures. Then we will solve it in two different way, and we will then we will use the SVM and DTW classification for the get the result, and then we get the comment and got to go. And then in detailed version you will see the detailed combination of our uh, how to extract our 2D features and how to extract our 3D features as well. Here for the hand segmentation we use the simple uh, hand depth threshold method, and as you can see in this picture you will see there's a two threshold here, which is a minimum distance threshold and maximum distance threshold. Basically, as in this picture, the hand segmentation uh, work by assume that the hand is the closest object from the camera. We select two distance threshold, which is a minimum distance threshold and the maximum distance threshold by trial and error, and then we keep the point clouds of the hand, which is belongs to between these two points, and then remove the points that not belong in these two threshold, which is the near camera points and after the max distance thresholds point. But somehow there's a arm that belongs to the hand that keep in there. To remove that arm we will have several steps also. First we will find the center points by averaging the point cloud of the hands after segmentation. Assume that our hand will in the up direction, which is as the picture A, and given the center point we will remove the point below which is the opposite of the up, which is the downside of the point itself, in some distance of a scalar that we got from trial and error, and it is represented as a red line at the B picture. Then we average the hand points after we got the hand arm removal. As you can see in the picture C, and then we will average the points again after the removal. The points belong to downside of the red line, and after we average the point we got the real palm points, and after that we can get the gesture type checking method that we will use for distinguish between a static and dynamic hand gestures. So basically the static gestures, well the hand is not moving a lot, so we just using the center of the hand data as which is the palm point that we got from previous method that we use. We record like 50 frames and calculate its velocity or movement. If it's below some threshold, which is means that the palm point or the hand is not moving a lot, and if it's higher than threshold, which is the, it's meaning that the point or the hand is moving a lot. So by this equation we got 0.01 as the threshold for this experiment, and if the hand velocity is higher than the threshold we mark it as a dynamic, and otherwise in the opposite side if the threshold is no is the average is the velocity is below the threshold, we will mark it as a static gesture. For 3D finger extraction, we basically we use a method called this is our method called 3D spare finger detection and 3D box finger tracking. The idea is first we remove some point cloth inside the spare from the palm point or middle point that we got from previous. After we remove the arm, so with this equation we remove the points that belong to the spare virtual spare that we have, and given the rest of point clouds, the clustering method applied to the rest of the points, and we will uh, use it as a to find the candidate of finger position. So we are using the 9 clustering size and remove the cluster that have a smaller size. We use the distance clustering for the clustering method. And as the cluster detected, we calculate 5 farthest point from the palm center as a candidate of fingers for each cluster. As I said before, the smaller cluster detected at the below some threshold will be removed, and not only the farthest in the term of Euclidean distance, but or other distance, but also in the term of the depth. So we will give the score to each point, which with this below equation, and the point with the higher score, that means it's likely the finger candidate. And after that we will calculate the angle of each candidate point, and the angle which have the angle is calculated by the 2 points, which is the palm and the candidate finger, and the angle will have the lower, we can mark it as a thumb, and after that the others will mark as a sequence of the finger, which is the index, middle, and ring, and the little finger. Here you can see the image A is the spare. You can see the circle head there is a spare method, and then we got the clustering with the different color, and after we calculate the angle and we mark it and as the candidate finger, I also calculate using the previous equation, and we got the C 5 fingers as we have. And here is the algorithm of finger detection. And after this finger detected, then it will mark as it will flag as the finger tracking. And for the finger tracking, from as soon as we get the finger position in the previous frame, then the next frame, the finger position estimation we can get by creating the 27 small cube from with the center of the previous finger position. And for each cube we calculate the sum of available point clouds, and if there's a some points in the point cloud belong to the one of the 27 cube, then we choose the cube with the higher score of with using the same previous equation to give a score of the candidate finger. If not, then we will use the finger detection method to extract the finger. And here's the illustration of the finger 3D tracking and finger algorithm here. And if the system able to track the finger, then we will keep tracking it, or keep giving the flag as the tracking, and if not, then we will change to the flag to the detection, so we can use the finger detection method for the next frames. And that's 3D finger detection, or for the finger extraction of finger position. And here we, for the 2D features extraction, Given the point cloud of the hand after arm removal, we project the hand into the 2D space. And using the binary threshold applied along with the canny edge detection, we got the contour of the hand and also the convex hull. And this with the help of the OpenCV library. Then we calculate the angle of the convex hull and also the selected contour points used as the features. We limit size of the contour point and select the points of the contour based on the difference of each contour point that have a very dramatical changing in the angle. And we set it as 12 point maximum from when we got it this number from when the hand is all in the open position. And here is, you can see that on the left you can see the color of the finger 3D fingers and the hand area and palm position selected contour with the green points and hull with the green line there and the palm position. We use that as a feature, so we will have the very big not very big we will have a big full feature, and then we will use the next method to use the gesture recognition system. Okay, now we are going to explain about the static gesture recognition. First, after we gather the data from the RealSense camera and then do the data pre-processing, such as hand segmentation, hand tracking, gesture type checking, and then we extract the 3D finger position and 2D hand contour features, and then we combine the features as explained before, and we are normalize the feature, right? Translation scales the features, and using SVM classification and using the SVM model that we are created before, we are trained it before, and by using that SVM model, we can get the result, the gestures. And in here, static gestures, if we are not gonna wait for the gestures, like I record 40 frames of gesture, we are not going that, we are directly, because the static gesture basically the gestures will, or the hand will be stay in the same way for each frames. And then we are moving to the, this is a step of the static gesture recognition as I explained before. Before we are doing the static gestures recognition, we record several frames of reference for the training data, including its features, extraction mentioned before, and then this record hand used for training SVM model. We record the data from 4 people, and it should perform only static hand gesture, and for each static gesture we got 200 frames, and then we use 90% as training set and 10% as the validating set. This trained SVM model then load to the system to be used with new data from a real-time captures camera, and then we extract the new data feature and using the SVM linear kernel a model as we trained before to predict the gestures. And moving on, we are going to explain about the dynamic gestures. In here is almost the same with the static gesture, but the difference is like we are record features in sequence, which is we are record like 40 frames. Actually, we are waiting the gestures to be finished to perform. Sometimes each dynamic gesture perform like more in 1 second, or in a normal frame per second is 30 frame per second. So we set like to 30 to capture or record a 30 frame, and then after 30 frames recording, we are doing the classification using a dynamic time warping for one sequence. And before we are, as the same as SVM, we are training the DDW using the reference data that we record before. As explained before, we record the sequence of the reference dynamic gestures around 40 frames, and this number as I get from the experiment that mostly people perform these dynamic gestures from start to the end is 40 frames, and then we load the sequence of the gestures reference to the system, then compare with the new real-time data. We record the new real-time data, and then we compare with the reference data that we use for training the DDW, and then given the sequence of new data, we compare it, and we got the distance for this from DDW, and the minimum distance for it will be classified as the result, and trigger some action to predict and we set some threshold of the minimum distance. So if this threshold is if the distance is higher than the threshold, then we consider it as an unknown gestures, or gestures is not in the reference or training set. Now to test the performance of our approach, we designed 9 gestures consist of the combination of 6 static and 3 dynamic gestures example. So we asked for users to perform gesture for 10 times each in a natural way. Each gesture is performed like around 200 to 100 frames, especially for dynamic gestures is performed like in a different frame number, and we conduct the test separately, and user asks to do the static gesture first, then dynamic gesture later, and there are total like 120 gestures for dynamic and 240 gestures for static, by each gesture is around 100 to 200 frames. The experiment setup using this hardware configuration of our system. This is Windows 10 in 64-bit operating system with the Intel Core i7 with a CPU 2.6 GHz, and then 8 GB RAM and 6 GB VGA GeForce GTX 950M, and the input device will be the RealSense SR300. the 3D camera or depth camera, and the system able to run smoothly at the real-time performance at around 40 to 50 frames per second. To calculate the recognition rate, this below equation was used. So basically it's just a correct gesture divided by number gestures performed and time 100%. Here is the gesture design. We have gesture 1 is dynamic gesture, which is the open door action. Gesture 2 is also dynamic gesture, which approach the mission. And dynamic 3 is dynamic gesture. Gesture 3, what I mean is gesture 3 is dynamic gestures push button. And also we have here 6 static gesture. First is handle toolbox, then static gestures grab tool, static gestures open menu, static gesture menu 1, static gesture menu 2, and the last static gesture is menu 3. For the result here we have showing that have several person here, 4%, and for the static and dynamic, which average of the static gesture is 93 accuracy, 93% accuracy, and now for the dynamic we have like 181.34% of accuracy. You can see that the person 2 have a lower recognition rate because its hand is a little bit smaller and it's hard to detect sometimes, and the dynamic gestures is more difficult from the static gestures recognition. As you can see from the result, you have a lower average result. We can see that the result is showing that our approach is good enough for the real-time performance and to detect the gestures or to recognize the gestures in real time. For the conclusion, the gesture recognition system for static and dynamic gesture has been presented. The approach using the combination of 3D and 2D space visual feature in order to solve the problem, and using the finger position, 3D finger position as 3D features, and convex hull and the contour of the hand as 2D features. We use the SVM model to solve the static gesture recognition and DDW for the dynamic gesture recognition problem. The experiment results show that the 93% accuracy of the static gesture problem in the average of 4 users, while 81.34% is for dynamic gesture recognition rate. This accuracy is quite low, maybe quite low for this problem, and in the future we will trying to solve several problems such as a missing finger in 3D space. That if we solve this missing finger problem, it could hopefully could increase the recognition rate, and using the well-known approach such as deep learning could also be one of the way. And we would like to implement these gestures in a real application of virtual reality application to test which is our gesture design is good or comfortable enough for the virtual reality application. Thank you very much for the listening our presentation. If you have any question, you can contact me in person in our email of one of our author. And here I am, the presenter is Nurkolis Lutfi Hakim, and you can contact me on skoliscall@gmail.com to for the further question of this presentation. Thank you very much.